Hello everyone, welcome to the next lecture on the Markov chain. Today I will explain how you can solve the questions related to the MH SET 2011 to 2023. I will explain you this with the help of the shortcut tricks. You can follow my YouTube channel where you can find the playlist of the CSR UGC gate and you can find the various lectures related to the various PY questions as here. Apart from them, if you are interested to watch on the Markov chain, you can see the December 2023 and PY questions of the Markov chain June 2011 to 23, PY question of the Markov chain December 2011 to 23, all are available here with the help of the shortcut trick. You must watch these lectures in order to understand the today's lecture in a very simple manner. So before I directly move on the PY question series, let me tell you firstly the various shortcut tricks, how you can solve the question in a very simple manner. So if you have the Markov chain with the finite state, like these are my finite states, and the corresponding the transition probability matrix is this one, then every year the two questions will definitely ask related to them. The first question maybe is related to the stationary probability, and another one is how you can identify the recurrent states or the irreducible states of the Markov chain. So first shortcut tips that I gave you, if you will see any of the diagonal entry is my 1, if diagonal entry is 1, then the corresponding state is called as absorbing state. If all the diagonal entries are my non-zero, if the diagonal entries are my non-zero, then the period of that state is always 1. So for example, if I say that my Markov chain is my this 0 0 1 1 0 0, so clearly say this is my non-1, so this is my state 1. So the period of the state 1 is my 1. If all the state has a period 1, then we call as the aperiodic. So in order to prove that whether it's a aperiodic or not, we call as period is 1. However, if the period is not 1, then we call as a periodic Markov chain. If the chain is irreducible, what is the meaning of the irreducible? You can start from the one state and you can move on the second, you can move on the third as well. Similarly, from the 2, I can move on the 1 and move on the third. So if all the state can be accessible from the either of them, then we call as the irreducible chain. If the Markov chain is irreducible and aperiodic, then we always get the unique stationary distribution. On the other hand, if your Markov chain is reducible, then we will have infinitely many stationary distribution. These are the notation that is called as the transition probabilities Pij, that is from the I to the jth stage. This is my time period. You can see in this case, this is the nth time periods. I call this is my n. And if I calculate the sum of all those possible paths, that means Pii of 0 plus Pii of 1 and so on, I call as the Fii. If this number is my less than 1, then we call as the state is transient. If my this value is my 1, then we call as the persistent or also call as the recurrent state. Another concept is the mean occurrence time, that is when you multiply this n. If this number is my infinite, then we call as a null persistent, and if this number is my non-infinity, or you can say it is a less than of infinity, then we call as the non-null persistent. Another thing is when you prove that the state is my transient, that means whenever Fii is less than 1, then the stationary probability distribution is always 0. And the sum of this, that means this number is my Fjg. You can see the definition of this is Fii for respect to Ii. If it is Jj, then it's Fjg. Remember that the stationary probability is 0 for the transient state. However, whenever you have the transient state, the limiting probability may or may not exist. Fine. For this, only for the transient state, then the limiting probability may not exist. If the Markov chain has a closed state, what is the meaning of the closed state is? I will explain you with the help of the example. If you prove that I is my transient, then J is also transient. If you prove that I is my recurrent, then J is also recurrent. If I consider the states are my 0 is like say this is my one class. If you prove that the 0 is my recurrent, then all the states are also my recurrent. If you prove that the period of the 0 is same as 7, then the period of the 2 is also 7. Period of the 3 is also 7, and so on. What is the meaning of the closed is? If you look about this, I have the state 0, 1, 2, 3. 0, 1, 2, 3. Closed means the sum of this each probability. The sum of the each probability is 1. Look at the 0 and 1. What is the 0, 1 is? This value. Fine. This is a 0, 1, 0, 1. Is the sum is 1 in each row? Yes. So then you can say 0, 1 is the closed state. Does the 2, 3 is the closed state? You can look about this transition diagram. 2 and 3 here. 2 and 3 here. This number. Is the sum is 1? No. Because you can see this is not 1. So that means this is my not closed. Now, how you can find the stationary probability? That's very simple. If you have the 2 cross 2 matrix like of this, because each sum has the 1, then the stationary probability is denoted by pi, which is written like of this. This is my state 0. This is say my 1. The first one will be B over the total, and this will be A over total. Fine. This is my stationary probability. Remember that always be the diagonal sum. If you have the n cross n matrix, then how you can find that? Whatever the matrix A, you can find the P minus I transpose. Fine. Then because it has a 3 cross 3, in general it's n cross n. Take any n minus 1 row. Take any n minus 1 row. And for example, I will explain you like this. For example, you have this case 0, 1 by 4, 3 by 4, 1 over 2, 1 over 2, 0. Fine. Then you can find the P minus I of the transpose 0. That means it's a minus half, half, 0. 0, minus 3 by 4, 3 by 4. 0, half, and minus half. This is my P minus I transpose. Take any two rows like of this. Minus half x plus 0y plus 0z is 0. Second row, half x minus 3 by 4y plus half of z is. So take any n minus 1 row, and the third one is the sum of them will be 1. Solve these three equations, you will get the stationary probability of more than 2 cross 2. Always remember the row sum is always 1. If you have the double stochastic Markov chain, what is the double stochastic Markov chain? Each row has a sum 1. Each column has also the sum 1. So whenever you have the double stochastic Markov chain, then the stationary probability will be 1 over n, and so on. What is the n is? Number of the states. If I consider this is my 3 cross 3 matrix, n is my 3. So then your Markov chain has the stationary distribution 1 over 3, 1 over 3, and 1 over 3. If you are new to my YouTube videos, you can simply scan and join my WhatsApp group for the various discussion parts. So let's start with the first question. How you can solve this PY question series? Your target is to find the probability of the 1 is 1. This means the state. Fine. How you can find the probability of the state? I can simply say x naught into probability. What is my x naught? Probability of the x naught is x. States are my 0, 1 and 2. 0, 1, 2. 0, 1, 2. So this is the probability of the 0. This is the probability of the 1. And this is the probability of this. Into P. What is my matrix? P is half, 1 over 3, 1 over 6, 0, 1 over 3, 2 over 3, half, 0 and half. My target is to find this. So you have the three answer. This is corresponding to the 0. This is corresponding to 1. This is. I need this answer only. So that means I can simply multiply the first row and the second column. So it will be 1 over 12. 1 over 12 plus 0. Answer is 1 over 6 is my right answer. This is the probability of the state at the 1. After this is my time period. So you have to calculate. This is the right answer. Okay, look at this one. There exists a unique, infinitely, and so on. Remember, when you will get the unique stationary distribution, if you prove that it's a irreducible and aperiodic. How you can check about the aperiodic? You can check about the diagonal. If all the diagonals are my non-zero, then it is aperiodic. You can see this is my non-zero. So that means it is not aperiodic. It is a finite Markov chain. Fine. So always remember, whenever you have a finite Markov chain, then all the states can never be transient. All states can never be transient at the same time. Fine. But it may be possible that all the states are recurrent, but all the states can never be transient. So all states are cancelled. Fine. Now, how you can solve this problem? So firstly, I can draw the diagram. So firstly, I can clear this screen. Can you draw this transition diagram? 1 to 1. Fine. 1, 2, 3, 4, 5. And then 1 to 3. 1 to 3. 2 to 1. 2 to 1. And 2 to 4. 2 to 4. Then 3 to 1. 3 to 1. 3 to 3. 4 to 4. 4 to 5. 5 to 4. And 4 to 1. Fine. This is the transition diagram. Now, clearly say, can you start from the 1 and reach at each stage? No, because you can never reach from 1 to 2. That means this state is my reducible. Fine. So this is my reducible Markov chain. Once this is a reducible, the unique distribution cancel out. Once it's a reducible, so how many stationary distribution? You have the infinitely many stationary distribution is the right answer of this problem. Okay, look at this another one. Again the states are my 0, 1, 2, 0, 1, 2. Draw the diagram. It's a 0, it's a 1, it's a 2. 0 to 0, 0 to 1, 1 to 0, 1 to 1, 1 to 2, 2 to 1 and 2 to 2. Now clearly say you can start from the 0 and reach 1 by this path, 1 to 2, 0 to 1, 1 to 2 possible, and so on. So each state can be reachable from any other states. So yes, this matrix is my irreducible. So the Markov chain is irreducible is the correct answer. Also, all the states do not commute. That's wrong, because you can start from the 0 and ending at 2, 2. All the states are commute each other. Again, you can see the diagonal entries are my non-zero. So that means this is also a aperiodic Markov chain. So what does it mean? The stationary distribution is my unique. Fine. The stationary distribution does not exist. That's a wrong answer. Fine. Now, P002. How you can find the P002? That means P square. How you can find the P square? And you will get the first number as P002. That means first row, first column, I can multiply them. So that means half, half, 0. And first column is half, half and 0. That is my P00 of 2. So what is the answer of this? 1 over 4, 1 over 4. That is half is the answer. But he said 1 over 4. That is the wrong answer. Fine. So that is the answer of this problem. If still you want to ask, now you can see this is the closed 0, 1, 2 is my communicating class. Now what is the period of the 0? Because the self loop, period of the 0 is my 1. So because they are the communicating class, so period of the 1 is also period of the all are my here. Clearly say 0 is my recurrent state, because you can start from the 0 and reach at everywhere. So it's a closed class. 0 is the recurrent, 1 is also a recurrent class or recurrent state, 2 is also a recurrent state. So the right answer is only D is the correct answer. Okay, now you can see it's a 2 cross 2, and what does it means? That means you have to find the stationary probability. Fine. You can see it's a finite. Fine. All the because alpha and beta are strictly lies between them, so the diagonal entries are non-zero. So that means it is my aperiodic. Fine. Also, if you draw the diagram, you can see 0 1, 0 to 1, 1 to 0, 1 to 1, and here it is irreducible also. Fine. So once it is a finite, if the Markov chain is my finite, aperiodic and irreducible, that means limiting probability is same as stationary probability. Fine, because they are talking about the limit, that means the limiting probability they are asking. So limiting probability is same as stationary probability. How you can find the 2 cross T? So if you remember that, if I say 1 minus A, this is B, 1 minus B. What is the stationary probability? B over the sum of them. Fine. So what is the answer of this? It will be beta over sum of them, alpha plus beta, comma, this will be alpha over alpha plus beta. Now your Markov chain has the state 0 and 1, and we need a 1 comma 1, that is this one. So this is my 0 1. So the right answer of this problem is P11 of n as n approaches. So alpha over alpha plus beta is the right answer of this problem. Okay, it's a double stochastic Markov chain. That means row sum is 1 and column sum is also 1. How many states are there? 1 0. So this is my Markov chain. 0 1 0 1. So when x1 is 1 to 1, probability is 1 to 1, probability is my P1. So this number will be 1 minus P1 because row sum will be 1. P0, 0 to 1, 0 to 1 is my P0. So this number will be my 1 minus P0. Then this is the Markov chain of x is equal to 1. So can you find the stationary probability? It will be 1 minus P1 over diagonal sum 1 minus P1 plus P0 and P0 divided by 1 minus P1 plus P0. Fine. Now your target is to find the pi 1. Pi 1 is here. Probability at the one stage. One stage is my here. So pi 1 is my P0 divided by 1 minus P1 plus P0. Now since it is a double stochastic, so sum of them will also 1. P0 plus P is also 1. So I can substitute here P0. 1 minus is my P0 plus P0. So that means half is the right answer. So pi 1 is my half is my correct answer. Okay, look at this another one. Again the Markov chain is my finite with the state are 0 1 2 0 1 2. Initial probability is this. Then your target is to find the conditional probability. So fine, that's a very simple. That's a P 1 to 2. What is the time period is 1. So that means your target is to find the P12. What is the P12? 1 over 4 is the right answer of this problem. Now which of the following is my closed set? What is the meaning of the closed set? The sum will be 1. 1 3 4. How many states are there? 1 2 3 4. 1 2 3 4. Now look at the 1 3 4. That means this number second row I can delete them. So does the sum is 1? Yes. It is 0.3 which is not 1. So it is not closed. Fine. Now look at the second option. For the second option 1 2 3, I have to remove the fourth column, fourth row. Is the sum 1? 1 1 1. Yes, it's a correct answer. 2 3 4. 2 3 4. That means I have to delete the first row, first column. Does the sum 1? It is not 1. So this option is cancelled. 1 2 4. 1 2 4. That means I have to delete the third row, third column. Third row, third column. Sum is not 1. Fine. So it means this is also not answer. C is my correct answer. Okay. your target is to find the probability x naught is my 2, comma x1 is my 1, condition x naught is my 2. That's very simple. You can see it's a conditional probability. I can write in the similar manner 1 to 2 time period 1. So again it will be 2 to 1 with that time period 0 to 1 is 1, and then 1 to 2 time period is 1. That's the answer. So this is the probability. States are my 0, 1, 2. 0, 1, 2. What is a P12? 1, 2. 1 over 4. 2, 1. 3 over 4. So right answer is 3 over 16 is my right answer. Okay. A two-state Markov chain. The states are my 0 and 1. So again you can see they are my finite states, and again you can see the diagonal entries are my non-zero, so that means it is a aperiodic. Fine. Again none of them are my 0, so it is also my irreducible. That means a unique stationary distribution observed. Pi naught and pi 1. Okay, fine. Okay, so your target is to find the pi 0, pi 1. What is the pi 0? 0 state, because it's a 0, so the diagonal entries are my q over q plus p, and pi of 1 state is p over q plus p. So first option is cancelled, B option is cancelled. Pi 0 is q over p plus q, and it's a p over this, and it's a p over, wrong answer. C is my correct answer. You can see, remember always my this shortcut tips. This is a purely a shortcut tricks which you can see only at my YouTube channel. Okay, consider the Markov chain. This is my 0, this is my 1, this is my 0, this is my 1. So again the diagonals are my non-zero, so that means this is my periodic. Fine. Now you can draw the diagram. 0, 1, 0 to 0, 0 to 1 no, 1 to 0, and 1 to 1. Fine. So is it possible that you can start from the 0 and reach at the 1? No. That means this is my reducible Markov chain. Fine. So it is, they are not talking about. Okay. How you can check about the absorbing? What is the firstly, what is the absorbing is? How you can check about the absorbing? Look at the diagonal value. Is the diagonal value is a 1? Yes. But he said the states, which state they are not talking about. It means we have to check the diagonal, all the diagonal value should be 1. It is not there. So that option is cancelled. Fine. If they are talking about the state 0, then state 0 is my absorbing. Fine. But right now they are not talking about only the state 0. So that option is, B option is cancelled. Now, how you can check about the transient or the recurrent? Look at that. Firstly, I will tell you the transient. Fine. Firstly, look about the column. Remember, this is a very simple shortcut tricks I will tell you. Fine. Always look about the column. Look at the column and find, look at the column which has only one value. Look at this column has the 2 value, skip them. This column has the 1 value. This value. What is the number of this number is? 1, 1. 1, 1 is my 1. Oh, sorry, it is my something. Make sure if this number is my not 1. Fine. If this number is my not 1, then only you can check about that transient. Firstly, I will tell you the tip. For example, if I say Pij is my non-zero and Pji is my 0, fine, then this state J is my transient. Fine. Then this state J is my transient. So look at that. Remember, only column which has only one value, then only this trick is applicable. So how you can do that? In this example, what is that? P 1 1 is my half, which is non-zero. What is the opposite of this? There is no opposite of them. That means this condition is satisfied. So that means this is my transient. Fine. Now look at this another one. Look at this another one. This is the one I can skip that. This number is my P10, which is non-zero. What is the opposite of them? Is my 0. That satisfied this condition. So that means this is my transient also. So 0 and 1 both are transient. So this option is correct option. Another way. This is the first method. Second method is, we can see about this diagram. So can you say about what is a recurrent? Firstly, is it possible that you can go from 0 to 1? No, you can never go from 0 to 1. That means 0 is not recurrent. So once one state is not recurrent, so this option is again cancelled. Erodic. What is the meaning of this? That means you can say non-null persistent. Non-null persistent plus aperiodic. Fine. So it's a aperiodic, yes, fine. But persistent means recurrent, but it is not a recurrent. So that means this option is also cancelled. Only the left option is my transient is the right answer. What is the meaning of that transient? If you start from the 1, you can go to the 0. Is it possible you can come back to the 0 or come back to the 1? Not possible. So that means this one is my transient. Fine. So that's why C is my right answer. Okay, look at that. Chain is reducible. So I can draw the diagram firstly. 1, 2, 3, 4. 1, 2, 3, 4. I will explain you this transient part also in the couple of the examples. It will be asked here. So 1 to 1, 1 to 2, 1 to 3 there is no. 2 to 1, that possible. 2 to 3, 2 to 3 possible. Fine. 3 to 1, 3 to 1 possible. 3 to 4, this is my 3 to 4 possible. 4 to 4 only. Fine. Now the chain is irreducible. What is the meaning of that? If you start from the 1, is it possible that you can go to the 2, 3 and 4? 1 to 2 possible. 1 to 2, 2 to 3 possible. 1 to 2, 2 to 3, 3 to 4 possible. Similarly, if you start from the 2, can you go from 1, 3 and 4? 2 to 1 possible, 2 to 3 possible, 2 to 4 again possible. From the 3, it clearly say 4 is not possible. Can you start from the 4 and reach at the 1? Not possible. So that means it is not irreducible. Fine. So this Markov chain is my reducible. Now 1, 2, 3 are communicating class. Is it true? You can see what is the meaning of the communicating class. It's not a closed, it's a communicating only. What is the meaning of the communicate class? If you start from the 1, you can go to the 2, you can go to the 3. Same for the others. 1 to 2, 2 to 3, 3 to 1. Fine. If you start from the 2, 2 to 1, 1 to 2, 2 to 3 and here. So that means, is it a communicating class? Yes, it's a communicating class. 1, 3, 4. If you start from the 1, can you go to the 1 to 3? 1 to 3 by using 2, but 2 is not there. Can you go directly from 1 to 3? No. So that means this is not communicating. 2, 3, 4 are closed. So closed means the sum will be 1. So it is a 1. I have to delete the 1. So now you can check that whether the sum is 1. No. So that means this option is also cancelled. Right option is only my C is the correct answer. You can see the diagonal entry is 1 correspond to the 4. So this 4th is my absorbing state. Fine. You can see this is a closed loop. 1 and 2. 1, 2, 3 are my closed loop. Fine. So this is my communicating class. And we know this is a self loop. So the period of the 1 is my 1. So that means the period of the, this additional information for you. Period of the D2 is also 1. 1, is there 1 is a recurrent state? Yes. Is it possible that you can start from the 1 and reach all the other states? Yes. You can start from the 1 and reach to the all state. So that means 1 is my recurrent state. So since it is my communicating class, so 2 is also recurrent state, 3 is also recurrent state, and 4 is my absorbing state. Okay, now you can see that it's a transient state. Firstly, look at that. States are my 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Look at the column. This has only one element. This number is my 3, 4. 3, 4 is my non-zero and non-1. What is the opposite of this? Check whether it's a 0 or not. 4, 3. It is my non-zero. So that means this is my not transient. Fine. It's a 3, 4. 3, 4 is my non-zero, but 4, 3 should be 0. That means 4 is my not transient. So it is already mentioned that. Now I will look about the one by one. Firstly 0, 2. That is my 2. This number is 1. This number is P1, 2, which is non-zero and non-1. What is my P2, 1? 2, 1, which is again non-zero. So what is the meaning of that? 2 is my not transient. Fine, this option is cancelled. Look at the fifth one. This number is 2, 5. What is the opposite of 5, 2? That's 0. So that means the one property is satisfied. This is my non-zero. 5, 2 is my 0. Look at this another number. 3, 5. 5, 3. You can see that. It means 5 is not transient. Fine. 5 is not transient. Look at the 3. Third is here. This number is my 2, 3. Make sure when you apply these shortcut tricks, this number should be non-1. 2, 3. 3, 2. Fine. This number is 3, 3. Fine. This number is 4, 3. But you can see 3, 4 is my non-zero. 4, 3 is my non-1 and non-zero. But 3, 4 is also my non-zero. So that means 3 is my not transient. So the only transient is my 0. 0 is my transient state. How? You can see about that. This is my 0. I can skip the 1. What is this number is? 1, 0 is my non-zero and non-1. What is my 0, 1? 0, 1 is my 0. So therefore, this is my transient. Okay. If all the states of the Markov chain are persistent, that's a recurrent non-null. What is the meaning of the non-null is? That is the mean occurrence time, that is a mu I should be finite. Now, when it has a unique stationary distribution, when it has irreducible Markov chain and it has a aperiodic Markov chain, it does not have a, what is that? This is a limiting probability. Fine. And it has at least one, that means it has infinitely many, at least one. So when it will be, okay, what is the nature of the Markov chain? Is it given that it's a reducible? No. So that means it may be reducible or it may be irreducible. Fine. So if it is irreducible, then the stationary distributions are my unique. But if my Markov chain is my reducible, then what will happen? Then you have infinitely many stationary distribution. Fine. So that means it does not have cancel out. Look at that. For all I and j, that is wrong option. Why? As I told you, if, remember that, if I say j, I have written j, if j is my transient state, fine, what is the shortcut tricks as I gave you? If j is my transient state, then the stationary distribution will be my 0. But he said strictly greater than 0. That is wrong option, because they are not talking about any of things. Now whether it's a unique or at least, you can see that if it is irreducible, then only 1. If it is reducible, then more than 1. So that means at least 1 should be definitely here, whether it's a reducible or irreducible, at least one should be there. So D is my right answer. Okay, now it's a branching process. So firstly I will give you the shortcut tips. If I say expected value of the xi is my say m, fine, and m will be my less than 1, and I start from the 1, 2 and 3. These are my offspring probabilities. These are my offspring distributions here, fine. Then the expected values of this I varies from 1 to infinity, xi is m over 1 minus m. This is the shortcut tips, always remember that, fine. Now look at this statement. This is start from the 0, but we need a 1, so I can write this component as x0 plus summation 1 to infinity of xi. Now if I open them, e of x0 is my 1, so it will be e of 1 plus e of this part, summation start from the 1 to infinity. Now what is the answer of this? E of 1 is 1. What is the probability of the offspring? Half. That is a mean, fine. M is my half, so if I substitute here, what is the answer of this? Half, 1 minus half. So 1 plus 1, 2 is my right answer. You can see that a very simple approach I have given you. Again, offspring probabilities, fine. Then your target is to find the intrinsic probabilities. Again I will apply the same rule. Firstly calculate the mean of this. So for the first case, what is my mean? Can I calculate the m? By using the mean of the xi's. So what is that? It's a discrete probability. So random variables are my x, 1 by 4 corresponding to the 0, corresponding to 1 p1, corresponding to 2 is my half. So what is the mean is 0, 1 over 4 plus 1, 5 over 4. Corresponding to this, it will be x and p, 0, 1 and 2. That's a 0, it's a 1 and it's a 2. So 1 over 4, 1 over 2, 1 over 4. Answer is 1. Correspond to the third case, it is x, it is p. Now they have the only two values. 1 will be 1 by 4, 3 will be 3 by 4. So it will be 7 by 4. Is it fine? Now look at the shortcut tricks. Shortcut trick. Now whenever m is my greater than 1, fine, then your extrinsic probability, that is this one, this, you have the two cases, either m is greater than 1 or less than equal to 1, fine. Whenever m is my greater than 1, your intrinsic probability should be less than of 1. Whenever m is my this one, then your extinction probability is my 1. So that means now you can see it's a 1 which is greater than of 1. Your probability will be less than 1. So the first case is less than 1, satisfied, 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 is equal to 1. Equality appear here. Your probability must be 1. You can see it's my 0. You can see it's a 0. It's a half. Only option is my here. This number is my greater than 1. This must be less than 1. So that's satisfied. So the right answer is C is my correct answer. Okay. Again, it's a branching process. This is the offspring probabilities. Now you can see the same shortcut tips as I gave you. Extrinsic probability, expected value is my m. Then it is m over m, 1 minus m, provided m must be less than 1. So that's a straightforward answer. Okay. Fij denotes the probability of the first returns. Following statements are correct. That's a very simple again. You can see my this shortcut tricks. What is the Pijn? You can see what is the Pii. Pii of n. That means probability of n step I from here. Fine. What is the FII? FII is my here. Now you can see, if you look about the option, only one, both one, all are. So that means the first one is obviously correct option. Fine. For any state, for the second, for any state, that means either the transient state or the recurrent state. So if it is a transient state, what is the value of this? You can see what is this number is. According to my definition, this number is my FII. Fine. So basically your target is to prove FII should be greater than or equal to 1 or not. And for this case again, FII should be greater than or equal to 1 or not. So if I consider in this case I is my transient, fine, so then what is the result? It should be less than of the 1, but he said greater than or equal to 1. You can see is equal to 1, but for the transient state we need a strictly less than 1. What does it mean? What does it mean? This option is cancel. So second option is my cancel. All are my correct, cancel. Fine. Now we have to see whether the third is correct or not. For the persistent, that means recurrent state, what is the case for the recurrent state or the persistent state? That is FII must be 1. So what is that? Equality hold. Fine. So basically this inequality becomes my FII is 1. So this is my correct option. Only option is cancel. C is my right answer. And you can see there is nothing to do much calculation if you remember my this shortcut tricks. Okay, Fij is the probability of the first visit. Fij is the probability of the first visit from this of here, fine, to j from I. So I to j. Oh, sorry, I to j. So it is from I to j with a finite state space. Fine. The following are the two statements. C is my close communicating class of the persistent states. That means recurrent. So I consider is a closed. So that means sum should be 1. And I say J and K are my two states, which is my closed. So half and half. Fine. So if this is my closed, so it means whatever, how many states are there? That's a finite state. So that all values are my 0. Then only the sum will be 1. Then for any transient state I consider this is my I state. Fine. Which is the transient? So I consider this number is to be, say, any of this. Say 3/4. Other number will be 1/4. Fine. And this can be any of the things. Then what is the value of the Fij? What is the Fij is? I to j. I to j 0. I to j 0. I to j and I to k both are 0. So that means both are same. That's the correct option. Fine. If C is my single clause, what is the meaning of the single clause? What is the meaning of that single clause? That means it has only one value. That means this is my absorbing state. Single clause means that is the absorbing state. So if I consider this is my 1. Fine. Which one is that? J. This is my jth state, which is only absorbing. And I is my outside of them. So I consider this is my any number. Say half and half. Fine. Clearly say this is my I and j. If I remove the ith states, the only number is my, this is my closed. Then Fij, half is a 1. Is it a 1? No. So that option is cancel out. So that means only 1 is my correct option. 1 is true, B is my false is the correct answer of this problem. So that's a very, very simple approach I have given. Okay, which of the following statements about the Markov chain? A unique stationary distribution exists. Unique. When it will be the existence of the unique? When you prove that it is my irreducible and periodic. Fine. If the Markov chain is irreducible, yes, this condition is fine, and periodic. First of all, the following are there. Okay, fine. So once it's irreducible, how you can prove the aperiodic? What is the meaning of the erodic? What is the meaning of the erodic is? That means recurrent and, or you can see the non-null recurrent or non-null persistent and aperiodic. So fine. So you can see aperiodic appears in this case. So 1 is the correct option. Only 2 cancel, either 3 or 4 cancel. Now we will see whether the 2 is, so it means 3, or moreover, if all the states are my transient, that will neither be a neither be the aperiodic. Null is there. No null persistent, that's the definition of the erodic. So the first and second are the right answer of this problem. Okay, consider the Markov chain of this for any state I. Okay, first one is the obvious C. What is the mu I? That is the mean recurrent time. If you remember that, what is the this is there, mean recurrent time, and the mean recurrent time is always be greater than of this probability, and this is the same case. Fine. So first one is the obviously correct option, and you can see only one correct option, 1 and 2, only 3. So only 3 will be the definitely be the wrong answer. But anyhow, I will prove that also. Persistent state, transient state. Fine. I can draw it look like here. If it is my say mu I here, since mu is greater than of this, so I call this is my FII. Fine. Now, firstly I can see the persistent, that means recurrent. Fine. For the recurrent state, what is the value of the FII? It must be 1. Fine. And if it is 1, then according to this, what is the mu I? What is the FII is 1. So that means this condition is also correct. For the transient state, what is the case for the transient state is FII must be less than 1, strictly less than 1. So that means if this is my F11, it must be less than of the 1. Fine. So where the 1 appears, 1 may appears at here, 1 may appear at here. So that means mu I, it may be less than 1, or mu I, if 1 appear here, mu I may be greater than 1. So that dependent upon the transition probability matrix. So this statement is not always correct answer. So that means first and second are my correct option, rest options are cancelled. Fine. What is the FIA? Is the first return. What is the FII? Is the probability of x1 to I condition, x0 to I, and mu I is the mean of them. So what is the mean? It's a n into FII. That is my mu I. So definitely you can see it's a multiply with the n. So n is my states number. So that will definitely mu I is greater than of. So first option is the correct option. Second option is the correct option by the definition of the recurrent. Third is a wrong option by the definition of the transient. Okay, look at this one. Which are the limiting probability, stationary probability, and here again 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Clearly say this is a 1 value. So what is that? P31 is my non-zero and non-1. What is a P13? 13 is my 0. So what does it means? This 1 is my transient state. Fine. Look at the second column. P32 again, which is my non-zero and non-1. But what is the P23, which is 0? So that means 2 is also my transient state. Fine. 3 is a 4, 3. 4, 3 is my, but it's a 1. We can't compute them. And here. So that means 1 and 2 are my transient states. And they are talking about the limiting probability and the stationary probability. What I told you. For the transient state, stationary probability will be 0, but the limiting probability does not exist. Okay, may not exist, sorry, it's a may not exist. So it exists for all. Does not exist, correct. There does not exist any stationary distribution, that's wrong. How? We can check about the diagram also. Fine. When it will be infinitely, when you have proved that it's a reducible. So I can draw the diagram. 1 to 2, fine. 1 to 4, only state is my 1 to 4. 1 to 4, 2 to 4, 3 to 1, where is the 3? 3 to 1, 3 to 2, and last one is 4 to 3. 4 to 3. Fine. Now clearly say this 2, 3, 4. 2, 3, 4. This is my communicating class. 1, 3, 4. 1, 3, 4 are my communicating class. So clearly say if you start from the 1 to 4, 4 to 3, 3 to 4, 4 to this and here. So that means this is my irreducible. Fine, because you can start from the 1 and reach at each of the states. So that means it's irreducible. So once it's irreducible, infinite Markov chain is not possible. Fine. Also, once is irreducible, there does not exist. That's also a wrong option, because once you have the irreducible, definitely a stationary distribution exists. Now, the two states, that is the 1 and 2, have transient states. So that means out of the 4, you have the 2 values 0. So that is always be the unique distribution. What is that? You can cross this. Now it's a 2 cross 2, but it is not a TPM. Fine. So you can get as a unique stationary distribution. How you can obtain the unique distribution? Again, very simple. I can start from the P minus I transpose. What is the P minus I transpose? Minus 1, 0, 0, 1. 0, minus 1, 0, 1 is a half, half, minus 1, 0, and 0, 0, 1, minus 1. Take any 3 numbers. So say minus x plus y plus z is 0. Minus y plus half z is 0. Third number is minus z plus w is 0. And the last one is x plus y plus z plus w is 1. So from here you can see x is my half of z, y is my half of z. From here z is my w. So clearly say if I substitute here, what is the x plus y plus z, or x plus y plus w? So it will be 2z is equal to 1. 1 plus 1, okay, plus of z. So z will be 1 over 3. Once z is 1 by 3, so you will all get as a unique distribution function. So yes, it's a unique distribution function. Okay, you can see that this is my infinite states. Fine. So always remember, when you have the infinite Markov chain, infinite states in the Markov chain, then your states are always transient. It can never be the recurrent. So there is all the states are my transient, are my right answer of this problem. Persistent means recurrent. So the right answer is only my D is the correct answer. Otherwise, if you want to draw the diagram also, you can complete the diagram. There is no issue. So 0, 1, 2 and so on. Fine. 0, 1, 2 and so on. What is the 0 and 0? Half. 0 and 1, half. Rest values. What is the meaning of this is Pi I minus 1 is my half. When I is equal to 1, 1, 0 is half. This is I and I plus 1, 1, 2, half. Rest values are my 0. Then 2, when I take 2, then it's a P2, 2, 1, 2, 1, half, and 2, 3, half, 0 and so on. So clearly say it's a double Markov chain. column sum is 1, row sum is my 0. And if you want to draw the diagram, 0 to 0, 0 to 1, 1 to 0, 1 to 2, fine, 2 to 1, 2 to 3, and so on. So clearly say, oh, I can start from the 0, reach at the 1, 1 to 2. So this Markov chain is my irreducible. Fine. So once this is irreducible, and you can see there is a self loop also there. No, it's a irreducible, but it has a infinite. You can reach at the 3, but you are unable to reach back to the here. So it's a infinite. So once it's a infinite, all the states are my transient. So the right answer is D is my correct answer. Okay, again you can see this is my infinite Markov chain, infinite state Markov chain. Fine. But here, if you want to draw the transition diagram, states are my 0, 1, 2 here, 0, 1, 2, and here 0, 1, 1. So rest values are my 0. I0 is my 3 by 4. So that means I is equal to 1, 1 to 0, 3 by 4, 2 to 0, 3 by 4, and so on. What is the Pi of T? What is the T? What is my T? So since this T is not clearly defined, what is the T? So I can skip this question for you. If you are able to understand what is this, what is the T, you can put your answer in the comment box. And then I will explain you in my next video how you can solve this question. Okay, look at this is the Poisson process of this. That's a very simple. If you remember that, that's a very straightforward about this. This is the standard result, but I will explain you if you want covariance. That is a x, this minus expected value of x, expected value of t. Fine. This is x, basically x of t. Fine. X is my Poisson process, t is my continuous random variable. Now let me firstly calculate one by one. I can firstly calculate the probability of this because I need an answer all in the terms of the t. T is the positive continuous which is independent of the xi. That means this is xt. They are dependent on this. That means the conditional probability will work. So once the conditional probability work, I can write this expected value of, I can write this part by using the conditional distribution. Fine. So what is that? This is my xt condition I, because they are my time homogeneous Poisson process and they are my independent. So this is my lambda times t, because it's the Poisson process with the rate lambda t. So this number will be my lambda times here. So if I substitute here, this will be e of t square. Now I can calculate the left hand side. This is x t into t. Again I can return this number as expected value of t into this, again xt I can return like this. Fine. Now since this is the expected value, I can return this t is my outside, expected value of, by using the conditional probability expected mean. So this is expected value of, what is the expected value of this? Lambda into t. So lambda is a constant, it is my e of t square. So that means lambda is outside, e of t square. So what is the meaning of that? If I take lambda is a common, what is the e of t square minus is variance. So otherwise you can remember that this is the standard formula for here. Again, this is similar of this, it's a covariance. This is a single number, but it is my 2 of this, and again this is my standard formula of here. Remember that if it is a time homogeneous, if it is independent of the time, then we all know this will be my, if they have the same xs and this, then you can see this is my time independent of this. That's a time homogeneous, that's a standard formula. Again you can derive this one with the help of the similar manner. Fine. How I can write that? This is the expected value of this into here. Fine. Minus expected value of this and expected value of this. Fine. Otherwise, you can remember that this is a standard formula which you can easily see in my previous lecture of the time homogeneous Poisson process. If you are new to my YouTube video, you can simply scan and join my WhatsApp group. So I will solve more questions in the next lecture. Till then, you can simply like, share and comment on my video. Best of luck, students. Happy learning.